In this example, we're going to graph a rational function with linear polynomials in the numerator and denominator. So for when we're graphing a rational function, we want to look at three different things. We want to look at whether there is a hole, a vertical asymptote, and a horizontal asymptote. So a graph could have multiple holes. It could have multiple vertical asymptotes depending on the denominator and the numerator and their factors. However, a graph can have one or no horizontal asymptote. And so looking at the holes and vertical asymptotes, we're really looking at the factors of the numerator and denominator. So our numerator is 2x plus 1. Our denominator is 3x minus 4. Neither of those are factorable because they are linear and they do not have common factors within each term. And so what that means is that since nothing will be able to reduce out, there is no hole for this graph. However, we will have a vertical asymptote. So a vertical asymptote occurs when the denominator is equal to 0. So we're going to take 3x minus 4 and set it equal to 0 and solve for x. And so that value will be our vertical asymptote. So that gives us 3x equals 4. So if we divide by 3, that tells us x equals 1 1/3 is the location of the vertical asymptote. So x is 1 here, so 1/3 is going to be a little bit past that. So let's draw a vertical line through 1 1/3 for this graph. The horizontal asymptote has to do with the degree of the numerator compared to the degree of the denominator. So since the numerator and denominator are both linear equations, right? So 2x plus 1 is linear. 3x minus 4 is linear. They both have a degree of 1. So since the degree of the numerator is equal to the degree of the denominator, that tells us that the horizontal asymptote occurs at y equals the ratio of the coefficients. So our coefficients are 2 and 3. So that means that y equals 2/3 is the horizontal asymptote. So our horizontal asymptote is at y equals 2/3. To graph this function, we want to draw a table, create a table of values. So we're going to plug x values into our equation to determine the y coordinates. What we want to do is pick two values that are on the left of our vertical asymptote and two values that are on the right side of our vertical asymptote. So that means that since our vertical asymptote is at 1 1/3, some good x values on the left would be 1 and 0. I guess I should write that as 0 and 1 if I'm doing this increasing. And then two values on the right of our vertical asymptote, since it's at 1 1/3, would be 2 and 3. So we want to use those x values to create this graph. To find the y coordinates of those points, what we're going to do is plug those x values into f of x. So f of 0 is 2 times 0 plus 1 over 3 times 0 minus 4. So the 0 creates that this is just 1 over negative 4. So at 0, our y coordinate is negative 1/4. So that's going to be about there. Then we want to evaluate f at 1. So 2 times 1 plus 1 is 3 over 3 times 1 minus 4 is negative 1. So that's going to occur at negative 3. So our y coordinate at 1 is negative 3. So what that means is that our graph looks like this on the left side of our vertical asymptote. So we have kind of a bottom left section is going to have the graph. So predictably, that means that we should probably have our answers appear on the top right when we plug in 2 and 3. So f of 2 gives us 2 times 2 plus 1, which is 5 over 3 times 2 minus 4. So 6 minus 4 is 2. So that's about 2.5. So at +2, we have a y-coordinate of 2.5. And then finally, we want to evaluate f of 3. So 2 times 3 plus 1 is 7. Over 3 times 3 is 9, minus 4 is 5. So 7 over 5 is 1.4. So that's going to be a little bit past 1. And so our graph is going to look like this in the top right section. So when we're graphing a rational function, we want to look at, can we factor either the numerator or the denominator or both? And then if we can, any of those factors that cancel will create wholes. However, we had two linear expressions, so we couldn't factor, which meant that our horizontal asymptote occurred at the ratio of the coefficients because these two were the same degree, they were both linear. And our vertical asymptote occurred at the 0 of the denominator. We picked two numbers to plug into the equation on the left of that vertical asymptote and two numbers to plug in on the right of that vertical asymptote. And so we use those values to create our graph. And so that is the process that you'll follow for any rational expression when you're graphing these rational functions.